Assalamu alaikum. This is Miss Linda. I hope you're doing well with distance learning. Today lesson, inshallah, we're going to solve some practice problems on elastic collision. So the objectives, we're going to compare between the conservation of momentum before and after collision and kinetic energy before and after collision in elastic collision. We're going to solve practice questions to find the final velocity of an object in elastic collision. Now, before we start, let's refresh our memory a little bit about elastic and inelastic collision. Here you see here this bar, the elasticity 100, it means I have the collision is completely elastic. What do I mean by completely elastic? If I hit the play button, okay, the two objects will not combine, will not become one object. They hit each other and each one of them, they move separately, either in the same direction or in different direction. But if I choose inelastic collision, the thing is different. If I hit the play button, after collision, both of them, they will move as one object. Now, this one, it could be two balls made of clay. It could be two balls made of magnet material. After collision, they will stick together and they will move as one object. And this collision, inelastic collision, actually exists in many aspects and many examples in real life. Like collision between two cars. After collision, they will collide and stick together and move as one object. Now, we will not focus on elastic and inelastic or perfectly inelastic. I have another type of collision which is this one is perfectly inelastic. Perfectly inelastic, they join and become like one object. Inelastic collision, it's in between, not completely inelastic and not elastic, completely is in between. If I hit the play button, okay, they will still, you see this one moves with a slow velocity, and there is a little bit here dent or a little bit deformation in one of the objects. It's like two cars, they hit each other. One of the car will leave a little mark or a little dent on the other car, or maybe both of them, they will have this small deformation. Now, let's read the first question, and after that, we will draw our table. Now, the first question says, I have 0.015 kilogram marble sliding to the right at this velocity 22.5 centimeter per second on a frictionless surface. So this is the first marble. It's moving to the right. Velocity is positive. So I will write this value. Now I can leave the value as it is, or I have to convert it to SI unit. So I have to convert from centimeter to meter. From centimeter to meter, I divide by what? I have to divide this value by 100. Okay, so this is the first velocity, first object. I'll give it a symbol 1, and it has M1 and V1. So this one is M1, the first object, and this one is V1, the first object, and is positive. Now mix an elastic hit collision with another marble. Both of them, they have the same velocity. Another marble, this is M2. This is M2, and of course it's moving with velocity V2. Moving to the left, which means the velocity should be negative, and again centimeter, I have to convert it, or I can leave it because both of them in centimeter. It's better to use SI unit. It's better to convert to meter. Moving to the left, so I have to put minus sign. After collision, the first marble, which is M1, moves to the left, so it changes direction, move to the left. When move to the left, it means you have to put the negative sign. So here, this is V1 initial. This one will become what? V1 final. This is after collision. After collision always is the final one. And find the velocity of the second marble. So I need this one, this object, the velocity of the second marble after collision. Now, again, This time, since I have to find the velocity and I need to calculate the kinetic energy, so I have to do my table. My table, I have two objects. The first object is the first marble. Second object is the second marble. Again, I have to write M1, V1, P1, and kinetic energy KE1. For the second object, I have M2, V2. This is P2 and kinetic energy KE2. And I have to fill out this table from the given itself. So M1, it's the same, doesn't change. V1, I convert it to meter. I convert all of these to meter. And here M2, the same thing, they have the same mass. V2 is negative. Okay, I need to find V2 final, second object, V2 final. Okay. How I calculate the momentum, it's mass times velocity. Mass times velocity, initial and final. How can I calculate the kinetic energy? I'm going to use the formula half m v square. So half, I have m, and v square, I write it down. Similarly, I finish this table. Now, what is the second step after completing this table? I have to apply the conservation of momentum. So conservation of momentum, P initial equal P final. Okay, P initial, this is from the table. I go back here to the table, go back to the table. What is P initial? P initial is these numbers, the number here, this one, this value, okay, this number, this one, this is initial value, and this is the initial value. I have to add them all. What is the final one? This is the final one. These two values. Since I don't have velocity, I just multiply these together and write it as it is. 0.015 V final, V2 final. Okay? So this is the initial equal final. I solve it. It's math, not physics anymore. And I need to find V2 final of the second object. Verify the kinetic energy since it's elastic. Whether it's elastic or inelastic, momentum is always conserved. But if I have elastic, only the kinetic energy is conserved, which means if I have inelastic, not elastic, if I have inelastic, the kinetic energy, it's not conserved. What do I mean by not conserved? Which means the kinetic energy initial does not equal the kinetic energy final. Here, since I have elastic collision, when I calculate the kinetic energy initial, okay, it should equal the kinetic energy final. So I have to add the number for the first marble plus the kinetic energy of the second marble. Kinetic energy, the unit is joule. Similarly, first marble plus the second marble. Second marble, I have the velocity, I can calculate it, which is half m, second object, times the velocity of the second object final, square, because I don't have it. If I add these numbers, you see, what do you notice? Both of them are equal. Inshallah, we'll continue the rest of the questions in the second video, inshallah.